2024 AMC 8, question 4. When Yunji added all the integers from 1 to 9, she mistakenly left it out a number. So one number is missing, we don't know which one. Her incorrect sum turned out to be a square number. What number did Yunji leave out? To solve this question, the strategy is going to be, firstly, what is the correct sum? Meaning, if I find out what's 1 plus 2 plus 3 plus 4 plus 5 plus 6, 7, 8, and 9, that's a correct sum. And then, what you need to do is to find out, is there a square number a little bit less than this correct sum, right? Because a number was missing, was left out, and you get a square. So try to find a square close to it. So that's a strategy. As you grow in your problem-solving skill, I also want to start talk about getting into the high-level strategy first, then figure out each steps. So for this one, we want to figure out what's a correct sum, and then we try to find a square next to it, or nearby, or not too far away from it. All right, how do you find the sum from 1 to 9? I do want to expand a little bit on this find the sum from 1 to 9 to like 1 to 100. So after we finish this question, but now I want to build an intuition for you on how to do this 1 plus 2 plus 4 plus 3 plus 4 plus 2, 9. Of course, you can do this one by one, but you are probably interested in, is there a trick to do this faster? There is a trick. If you look at this equation, 1 plus 2 plus 3 plus 4 until 9, and you think about reversing it, meaning another equation. 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. What's interesting is that if you change the order of how do you do the sum from 1 to 9 or from 9 to 1, you should get the same answer. So technically, those two expressions, if I add them up, I should get 2 of my answer. But then, when you try to add those two expressions up, something will become interesting. Because as you do the summation, you will notice 1 plus 9 is 10. And that's why reversing the order is super helpful. Because then you'll find 2 plus 8 is also 10. 3 plus 7 is also 10. And every term here is 10. How many 10s do we have? We have 9 of them. So when you add those two lines together, you are going to get 10 times 9. But remember, this is 2 times the number you need because we repeated those line 2 times. We write it out first, then we reverse the order. So to find the correct sum, we need to divide this by 2. And this is going to give you 45. Now, we move on to our step 2. We need to find the square close to it. It's much easier to find the squares and see which one is close to 45 because there are not a lot of them. So I start from 1, 4, 9, 16, 25, 36, and then 49. Remember, you miss a number. Yunji missed a number, so the square got to be smaller than 45. So we need to cut off 49 and everything after that. After you cut that off, the closest square is going to be 36. So instead of 45, Yunji gets 36. Which number was missing? Well, what's missing is going to be 45 minus 36. and that is 9. So the answer for this question is 9. I want to use 2 videos to expand on this add numbers from 1 to 9, 1 to 100, blah, 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 because it's going to be very useful for other contest questions. So let me use one more slide to do it. Now, let's just try a new one that you can't really do the sum by adding every number up. Because 1 to 9, technically, you can just do the addition. You'll get it. Let's do this famous 1 plus 2 plus 3 until 100. How do you find this sum? Same idea. Reverse it first. You'll get 100 plus 99 plus 98. Continue up to 1. And yes, one more time you will find when you try to add those 2 lines together, every position give you the same number, 101, 101, 101. Now, how many 101 do you have? We have 100 of them. So 101 times 100 and divided by 2, you will get 5050. I'm going to now write out the general expression, but I do want to see if you can remember this trick. You don't really need to remember that equation. It's much easier to just visualize it, to say, okay, take the sequence, reverse it, add them up. The key thing is to remember, divide the answer by 2, but I want to give you the equation. So the general equation is going to be, if I get a bunch of numbers from A1 to AN, and they increase by 1 for each term. In the future, you'll find it actually also works if they increase by 2 for each term, increase by any fixed amount. To find the sum, it's going to be equal to the first term plus the last term. In our case, the first term you have is 1. The last term you have is 100. Again, why do you add the first term and the last term together? It's because if you flip it, the last term becomes the first, and you're adding them up. Now, how many 101s do we have? We have 100 because that's a number of terms. So you time this by the number of terms. And in the end, you need to remember to divide this by 2 because we repeated those line twice. So it has been repeated twice. You need to remember to divide it by 2. Again, one more time. It'll be great if you can remember this expression or this equation and use it. But if you can't remember it, remember the intuition behind it. It's going to be very handy. Thank you.